Explanation. Consider the following list of numbers: 1, 1, 3, 5, 7, 9, and so on. 2, 1, 4, 9, 16, and so on. 3, 8, 16, 32, 64, and so on. 4, 0, 2, 4, 6, 8, and so on. 5, minus 5, minus 8, minus 11, minus 14, and so on. 6, 1 upon 1, 1 upon 2, 1 upon 3, 1 upon 4, and so on. In each of the above list of numbers, there is a specific relation between consecutive two numbers. 1. In the first list, we get every successive number by adding 2 to the previous number. 2. In the second list, the number in the first place is the square of 1. The number in the second place is square of 2. The number in the third place is the square of 3, and so on. Sequence. A sequence is a collection, list of numbers arranged in a definite order according to some definite rule. Each number in the sequence is called a term of the sequence. The number on the first position is called first term and it is denoted by T1. The number on the second position is called the second term and it is denoted by T2. In general, the number in the nth position is called the nth term and is denoted by Tn. A sequence is usually denoted by curly bracket Tn and read as sequence Tn. Sum of the first and terms of a sequence. If curly bracket Tn is a sequence, then we denote the sum of the first and terms of this sequence by Sn, where Sn is equal to T1 plus T2 plus T3 plus and so on plus Tn. Thus we see that S1 is equal to T1, S2 is equal to T1 plus T2, Sn is equal to T1 plus T2 plus T3, Sn is equal to T1 plus T2 plus T3 plus and so on Tn. From the above sequence, we see that S1 is equal to T1, S2 minus S1 is equal to T2, S3 minus S2 is equal to T3, Sn minus Sn minus 1 is equal to Tn. Therefore, Tn is equal to Sn minus Sn minus 1. Thus, if general form is given, open bracket, Sn is equal to n plus 1 upon 2, close bracket, then we can find any term of that sequence. Types of sequences. If the number of terms in the sequence is finite, then it is called a finite sequence. Otherwise, it is called an infinite sequence. We have the following main distinctions between sequences and sets. Sequences, sets. 1. The elements of a sequence are in specific order. 1. Elements are at random. 2. The terms of sequence cannot be rearranged. 2. Elements can be rearranged. 3. The same value can appear many times. 3. Any value can appear only once. Example, for each sequence, find the next 4 terms. 1, 1, 2, 4, 7, 11, and so on. Answer, given list is 1, 2, 4, 7, 11, and so on. T1 is equal to 1, T2 is equal to 2, is equal to T1 plus 1. T3 is equal to 4, is equal to 2 plus 2, is equal to T2 plus 2. T4 is equal to 7, is equal to 4 plus 3, is equal to T3 plus 3. T5 is equal to 11 is equal to 7 plus 4 is equal to T4 plus 4. Therefore, Tn is equal to Tn minus 1 plus n minus 1. T6 is equal to T5 plus 6 minus 1 is equal to 11 plus 5 is equal to 16. Similarly, T7 is equal to 16 plus 6 is equal to 22. T8 is equal to 22 plus 7 is equal to 29. T9 is equal to 29 plus 8 is equal to 37. Therefore, for given list, next four terms are 10, 16, 29, 37. 2. Find the first five terms of the sequence whose nth term is Tn is equal to 4n minus 3. Answer. Here Tn is equal to 4n minus 3. T1 is equal to 4 into 1 minus 3 is equal to 4 minus 3 is equal to 1. T2 is equal to 4 into 2 minus 3 is equal to 8 minus 3 is equal to 5. T3 is equal to 4 into 3 minus 3 is equal to 12 minus 3 is equal to 9. T4 is equal to 4 into 4 minus 3 is equal to 16 minus 3 is equal to 13. T5 is equal to 4 into 5 minus 3 is equal to 20 minus 3 is equal to 17. Therefore, first five terms of 4n minus 3 are 1, 5, 9, 13, 17.